Hello, my math friends. It is I, your math teacher. We're going to do lesson 10.2.1, transforming functions. This one's not too bad a one. It's going to be rather easy. All right, so we've got the city pool wants to install a water slide. That sounds like a good idea. Your team has been hired to create plans for the slide. However, the pool regulations state that the ladder must have a slope of 3/2. And the slide to be used must be made using the equation h of x equals 10 times 1/2 to the x power, where h is the height of the slide and x is the horizontal distance in feet from the top of the ladder. Assume the ladder ends and the slide starts at the y-axis. Okay, so here's our ladder, L of x equals 3/2x, and here's our slide, h of x equals 10 times 1/2 to the x power. So let's go ahead and make a quick graph here. So I'm going to put my, let's put it right there. There's my y-axis, x-axis. I think I'm going to need some room here, so maybe I'll put this one right here-ish. All right, so L of x is going to be 3/2x, so that means the y-intercept would be at 0. So there's my first point. Then it's going to go up 3 and over 2. So up 1, 2, 3, and over 1, 2. Up 3 over 2. Up 3 over 2. All right, there's the slide. Oh, down 3. Down 3 backwards 2. What? Yep, I can do that. All right, so we've got our ladder to climb up to the slide right there. All right, so that is L of x. H of x, the actual slide. So the a value is 10, so that means that my y-intercept is at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we've got the multiplier is 1/2, so that means I'm dividing every single time. So 1, 2, 3, 4, 5. So the next point would be at 5. The next point would be at 2.5. The next point would be 1.25, then 0.75, and then 3/8. Okay, so we know that the asymptote there is going to be at y equals 0. So let's just make the slide here. Oh, that's not a very good curve. Oh, I'm going to be fired for this one. Okay, I did better at the end, so don't fire me. All right, so there's our slide, and there's our stairs moving up to the slide. Now, there's a little bit of a problem here. The stairs don't take us to the top of the slide. That's a little bit of a problem. So the top of the ladder needs to meet the top of the slide. How can we change the equation of the ladder to make this happen? Well, this equation needs to have the y-intercept way up here instead of way down here where we have it. So if I had L of x, I would need to increase the intercept, so I would need to shift it up 10 units. So if I do L of x equals L of x plus 10, that would shift my output up 10 units. It would move everything up 10 units. So that would move it up there. And if I do L of x and shift everything up 10, then this point would move up 10 units. So this point would be right here. This point here would move up 10 units. So it would be right here. Yeah. And then some other points that we hadn't graphed before would show up back here. And our new line is going to be parallel to our old line because the slope didn't change. The only thing that changed is we shifted it up 10, which changed the y-intercept. And now we can climb up the slide, or up the stairs, and go down the slide. And everybody's happy. Assuming the other slide drops swimmers off right at the height of the water. So wherever it's dropping it off, it's right at the water's height. Use a function notation to change the functions so that the new slide will drop off a swimmer 3 feet above the water. All right, so let's start with L of x. L of x, if we move everything up 3, Well, I already moved it up 10, so I would end up moving it up 13. And then the slide portion, h of x, I haven't done anything to the slide. It's at 10, but I want to move everything up 3, so I would shift it up 3 by adding 3 to the output. So when I add 3 to the output, everything shifts up 3 units. So let's look at a graph here. So looking at, let's look at the new L of x, which was L of x plus 10. It used to be at 10, but we shifted the graph up 3, so it's up 13 from the original. So now I'd go up to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where it was before. And then I shifted it up 3 more units, so 1, 2, 3. There's new graph. The slope is still the same. Down 1, 2, 3, back 2. Down 1, 2, 3, back 2. All right, there's the new slide. Or not slide, ladder. Words are hard. We're trying to work through it. Down 3 over 2, down 3 over 2. Yeah, it looks right. So there's our ladder. That's L of x. So this is L of x. L of x was only 3/2 x, so we added 13 to it to shift the whole graph up 13 units. Now, h of x used to have a y-intercept at 10, but now I shifted it up 3 units. So the output of 10, we're going to add 3 to it. So now the output's going to be right up there at 13 where we want it. Now this output, if I plug in 1, I end up with 5. So my output's 5, and then I'm going to add 3 units to it. So now it's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. So I don't take half of the 13. That's not what I'm doing. I'm taking this graph and then just moving everything up 3 units. So every point will move up 3 units. So this point here was at 2.5. If I add 3 units to it, it'll be up at 5.5. 1, 2, 3, 4, 5.5. This point was at 1.25, so now it's going to be 4.25. 1, 2, 3, 4.25, and so on and so forth. Now the asymptote also moved up 3 units. So now my horizontal asymptote here is going to be at y equals 3. So my asymptote used to be on the x-axis, but that was dropping them off at water level. I now want to drop them off 3 feet above the water. Oh man, I'm going to be fired. These are really bad graphs. I apologize. All right, there it is. So we've shifted everything up 3 units. Team Metro submitted slide M of X for review. Unfortunately, their slide ends 2 feet below the top of the water. That's a horrible slide. 2 feet below the top of the water. So they got a problem. So if I wanted to change their function, I need it to at least go at the water level. So if I wanted it to go at the water level, I would take their function and shift it up 2 to be at the water level. Now, if I wanted it to drop more than that, it's possible. I could do this M of X plus 3, and then it'd be a foot above the water level, or what have you there. So they had problems. Team Metro, you have failed. So we're going to add 2 to their graph, so at least they're dropping them off at the water level. Team City submitted C of X for review, so that's their slide they want to build. But their slide drops them off 4 feet above the water level, and pool regulation states that slides must drop swimmers off at a maximum of 3 feet. So it's too fun to drop it off at 4 feet, so we got to lower that some. Okay, we got to limit the amount of enjoyment that people get. So I want to drop it a foot, so for C of X, I would just subtract 1. And then that would shift the whole graph down 1 unit. Pretty easy, right? X side. All right, so here we've got f of x. There's the graph. We want to do two different things to it. First, we want to do f of x minus 1. That will shift this graph down 1 unit. So anywhere you see a lattice point, like here, I'm just going to shift it down 1 unit. Here's another lattice point, down a unit. Another lattice point, down a unit. This one, down a unit. This is a lattice point, down 1 unit. Here's another lattice point, right there. Here's a lattice point. That's going to be right here. Here's another lattice point. That's going to be down 1 unit. Another lattice point, down a unit. No lattice point, no lattice point. Looks like another kind of lattice point there. So there's our last one that we're going to do. So if I shift that function down 1 unit, that's what f of negative 1 means. Our new graph is going to look like this. And then, oh no, I have to draw another curve. Here, let me spin my paper a little bit so I can actually get this curve right this time. All right, so okay, that's better. I can keep my job. All right, so basically the whole graph just moved down 1 unit. If I want to do f of x plus 3, that would just take all my lattice points and move them up 3 units because I'm just increasing the output by 3. So this would be 1, 2, 3. That would be there. This would be 1, 2, 3 right here, so on and so forth, and such. And this would be 1, 2, 3 right there. This point here would be up 1, 2, 3. It'd be right here. This point 1, 2. Wait, no, 1, 2, 3 from here. 1, 2, 3. And then this point would be 1, no, here. 1, 2, 3. I keep on picking the wrong part of the graph. Let's see. This point here would go up 1, 2, 3 here. This point 1, 2, 3 here. And then this last point 1, 2, 3 right about there-ish. All right, so f of x plus 3, we're getting this new graph, which looks exactly like the old graph, except it's up 3 units. And then we got to make this dangerous curve again. For some reason, it's easier to do the curves when it's tilted sideways. I don't know why that's true. Anyways, so this one would be f of x, and then we added 3 to the output, so we shifted it up 3. And this one would be f of x minus 1, and we just shifted all the outputs down 1. All right, that's the math you got today. Math hard. See you later. Bye-bye.